future doctors. My name is Prachi and I am your chemistry SME. So let's start with the video solution of Brahmastra part test 2. In the chemistry section A, so as you know that this chapter mainly comprises of solution chapter, right? So let's start with the questions. In question number 51, it is said that which one of the following aqueous solution exhibits highest boiling point? Okay, it is asking that which of the following aqueous solution will exhibit the highest boiling point, whether it is 0.01 molar Na2SO4, 0.015 molar glucose, 0.015 molar urea or 0.01 molar NaCl. Here it is molar. Okay. So among all this, which has the highest boiling point? So let's read the solution. Let's find out the solution. So we know that Tb is equals to IKB into M. Okay, Tb is the elevation in boiling point. Now, elevation in boiling point, we know that it is a colligative property and it depends upon the number of solute particles. It depends upon the number of solute particles. The greater the number of solute particles in the solution, the higher will be the extent of elevation in the boiling point. Okay, so Tb, the elevation in boiling point increases as the number of solute molecule increases, right? So in the first option, we can say that Na2SO4. So Na2SO4 dissociates into 2Na plus and SO4 2 minus, right? So this will contain the maximum number of ions. Na2SO4 will contain the maximum number of ions and hence it will contain the maximum number of solute molecules and similarly it will have the highest boiling point or highest elevation in boiling point. Okay. So option number 151 for question 51, option number 1 is the correct option. Next question is question number 52. In question number 52, in a mixture of A and B, components show a positive deviation. When a positive deviation is shown in mixture A and B, AB interaction is stronger than AA and BB interaction. AB interaction is weaker than AA and BB interaction and V mix is less than 0 and S mix is greater than 0. V mix is equal to 0 or S mix is greater than 0. So among all these options, which one is the correct? See, option 2 will be the correct option here. Why? Because when AB interaction is weaker than AA and BB interaction, okay, so it is clear that AB interaction is weaker than AA and BB interaction, then only we can expect that there is a positive deviation in mixture A and B. So positive deviation from Raoult's law occurs when the vapor pressure of the mixture is higher than predicted. Okay, so vapor pressure is higher than predicted and it happens when the intermolecular spaces between the different components, here we can say A and B, these are weaker than the interaction between their like components. Okay, so when the interaction between AB components is weaker than their like components, which means AA and BB components, then only we can expect that there is a positive deviation in the mixture. Okay, there is a positive deviation. Next is question number 53. In question number 53, the molar elevation constant of water is 0.52 degrees Celsius. The boiling point of 1 molar aqueous KCl solution therefore should be. So we have to find out the boiling point of aqueous solution of KCl. Okay. So here the boiling point we have to find out, which means we have to find out what? We have to find out the Tb. Okay. We have to find out the Tb. Tb we don't know. And in the question, what else is given? And in the question, it is given that the molar elevation constant, which means Kb value is given as 0.52 degrees Celsius. Okay. I value, we know that I value we have 2. I value we have 2. Okay, and the molarity is also given. Molality. The molality is given as 1. Okay, molality is 1 molar. So these all are given in the question, and what we have to find? We have to find Pb. So similarly, we will put the values in the following equation. So delta Tb, we know that it is 2 into Kb into m. Okay, and for ICL, for KCl it is 2. So here it will be I. Okay, so which means that delta Tb is equals to I into Kb into m. M is the molality. Okay, m here is the molality. So I here is 2 and Kb value is given in the question as 0.52 and molality is given as 1. So delta Tb comes out to be 1.04. Okay, 1.04. Now we have to calculate what is Tb. So Tb we know that it is Tb plus delta Tb. Okay, this will be the formula. So Tb is 100 and delta Tb is 1.04, which means that the the boiling point elevation is 101.04. 101.04, which means option number 3 is the correct answer. Okay. For the theory part, you can refer to the detailed explanation section. In question number 54, the following solution were prepared by dissolving 10 gram of glucose in 250 ml of water, 10 gram of urea in 250 ml of water and 10 gram of sucrose in 250 ml of water. The right option for the decreasing order of osmotic pressure of these solutions are. Okay, so here we have to find out or we have to compare the osmotic pressure of these three solutions. Okay, so we know that the formula for osmotic pressure, what is the formula for osmotic pressure? Pi is equals to ICRT. Pi is the osmotic pressure, C is the molar concentration of the solution, R is the gas constant and T is the temperature in Kelvin. Okay, so now let us see the other. Okay, the formula for osmotic pressure we know. Now with the increase in molar concentration, the solution of osmotic pressure increases. Okay, with increase in molar concentration of solution, osmotic pressure increases as the molar concentration will increase. As the molar concentration will increase, the osmotic pressure will also increase. Okay. Now, since weight of all the solutes and its solution are equal, higher will be the molar mass, the smaller will be the molar concentration and smaller will be the osmotic pressure. So, molar concentration, osmotic pressure, these two relation we know. Now, molar mass should be less, which means that molar mass, the compound or the solution which is having the less molar mass will have more molar concentration and more osmotic pressure. Now here we have to find out that which has the greatest molar concentration, that solution will have the greatest osmotic pressure, which means that it should have the least molar mass. Okay, so the molar mass, if we see the order of molar mass, then sucrose will have the greatest molar mass, then glucose, then urea. So the order of osmotic pressure should be reversed. Okay, so the order will be sucrose 1. Okay, glucose here is given as P1 and urea is given as P2. Okay, I am writing with other color. It is given as P1, urea is given as P2 and sucrose is given as P3. Okay, so if we consider the molar mass, if we are considering the molar mass now, so sucrose will have the greatest molar mass, then glucose, then urea. So what will be the order of osmotic pressure? P2 will be the greatest, then P1, then P3. Okay, so this will be the correct order of osmotic pressure. So P2, P1 and P3. P2, P1 and P3. Option number 2. Option number 2 will be the correct option. Got it? Next is question number 55. So in question number 55, In question number 55, the vapor pressure of a solution at 45 degrees Celsius with benzene to octane in the molar ratio 3:2 is, okay, uh, at 45-degree vapor pressure of benzene is 280 mmHg and that of octane is 420 mmHg. Assume ideal solution. So for question number 55, what we have to do? Vapor pressure of solution at 45-degree temperature is given with benzene and octane. So molar ratio is 3:2. Okay. So the number of moles of benzene into number of moles of octane is 3:2. It is given. So mole fraction, what will be the mole fraction? It will be 3/5 and the mole fraction of octane will be 2/5. Okay. Now you can see properly. So what will be the vapor pressure? So vapor pressure is P naught of benzene into mole fraction of benzene plus P naught of octane by into mole fraction of octane. Okay, by this formula we can find out the vapor pressure of solution. Vapor pressure of solution. Now this equation is the vapor pressure of solution. So 280 is the vapor pressure of benzene and 3/5 is the mole fraction of benzene. Here we have seen, and 420 is the vapor pressure of octane and 2/5 is the mole fraction of octane. Okay, so on solving this we will get 336 mmHg as the correct answer. 336 mm of Hg. Okay, option number 4 is the correct option. Now the next question for question number 56. For question number 56 now, which of the following graph is the correct representation of Henry's law? So see, for Henry's law, this is the question which you can see in every other question paper. So this I am marking as important question. Okay, so like this you just have to remember the graph. So let's read the explanation for this. Now according to Henry's law, we know that M is equals to Kp. Here M is the solubility and K is the Henry's constant, P is the pressure. Okay, so now when we are taking the log on both sides, then what will happen? Log M is equals to log K plus log P, and when we compare this equation 1 with this, y is equals to mx plus c. Okay, it is the equation for what? It is the equation for straight line. So it comes that mx equals to log p and c is equals to log k. So when log m is plotted against log k, a straight line is obtained with a slope and intercept of log k. Slope is L. Slope here is L. So which of the following graph is the correct option for this? Okay, it is a straight line. So option 2. Option 2 will be, sorry, option 3. Option 3 will be the correct option. Okay, not option 3. Okay, this is for, wait a second. Yeah. So option 2, this is for option 2, this is for option 3. Okay. What is happening? Yeah, sorry. So this is for option 3. Option 3 is the correct option here. Okay. And in the answer key also, I think it is option 2 is given. So option 3 is the correct answer. It should be straight line which is passing through the origin. Okay. See, this is the correct answer. For detailed explanation, you can, for detailed part, you can see the detailed explanation one. Okay. Now, question number 57. For question number 57, 200 ml of water is added to 500 ml of 0.2 molar solution. What is the molarity of this diluted solution? Okay, we have to find out the molarity. 200 ml, which means that 200 ml, which means V2. V2 here is given as 200 ml, and when we convert it into liter, what is it? It is 0.2. Okay, let it be. Let it be 200 ml first. Okay. Now is added to 500 ml solution. It is added to 500, which means V1 is 500 ml, and M1 is given as 0.2 and M2 we have to find out. So it is a easy formula. Just we have to put these values in M1 V1 equals to M2 V2 formula. M1 is 0.2, V1 is 500 ml, M2 we have to find out, and V2 is 500 plus 200, which is 700 ml. Okay, V2 is 700 ml. 200 ml of water is added to 500 ml, it is written. So these two have to be combined. So 700 ml, and here we can find out the M2, it is equals to 0.14 molar. 0.14 molar, option number 4 will be the correct option. Okay. For question number 58, question number 58, determine the osmotic pressure of the solution prepared by dissolving 25 milligram of K2SO4 in 2 liter of water at 25 degrees Celsius, assuming it to be completely dissociated. Now, determine the osmotic pressure of the solution. Osmotic pressure, which means pi, we have to find out, and it is prepared by dissolving 25 mg of K2SO4. Okay, 25 mg of K2SO4 is there, which means the uh, weight is given, or you can say mass is given as 25 mg, and volume is given as 2 liter. Okay, assuming it to be completely dissociated. So let us see. Volume here is 2 liter. Temperature is 25 degree. Temperature is 25 degree, which means 25 plus 272 in Kelvin we have to calculate. So it is 298 Kelvin. Now the reaction of dissociation of K2SO4. So K2SO4 on dissociation, what it will give? 2K plus SO4 2 minus, right? So from here we can find out the Van 't Hoff factor, which is I, and here it is 2 moles plus 1 mole, which is 3. 3 is the Van 't Hoff factor. Now we will use the osmotic pressure formula, right? So pi is equals to I into N by V RT. By this formula we are going to calculate the osmotic pressure. Okay. So N by V, other than N by V, we can write as W by MV also. Okay, because number of mole, what is number of mole? Number of moles equals to moles of solute by molecular mass. Given moles, given mass by molecular mass. Okay. So R is the gas constant, 0.0821 liter ATM per Kelvin per mole. Molar mass of K2SO4 we can calculate as 174 gram per mole. So on substituting all this value in osmotic pressure formula, we will get pi is equals to 5.27 into 10 to the power minus 3 atm. Okay, 5.27 into 10 to the power minus 3, which means option number 2. Option number 2 is correct for 58 question. Okay. Next is question number 59. The vapor pressure of pure liquid A and B are 100 and 200 mmHg respectively at 300 Kelvin. If the total vapor pressure of the mixture is 175 mmHg, then the mole fraction of the component A in liquid and vapor phase respectively are. Okay. The vapor pressure of pure liquid A and B. The vapor pressure of pure liquid A and B is given. It is 100 and 200, which means P naught of A is given as 100 and P naught of B is given as 200 mm. Okay. Now, if the total vapor pressure of the mixture, which means PT, total vapor pressure is given as 175 mmHg, then we have to calculate the mole fraction of component A in liquid and the vapor phase. Now we can calculate the mole fraction of A we have to calculate. Okay. Now let us see. PT, we will use this formula of total vapor pressure. PT is equals to P naught A into XA plus P naught B into XB. Total pressure is given as 175. Total pressure is given as 175. P naught XA, and we can write XB as 1 minus XB, as no XB is given in the question. So we can take XB as 1 minus XA. So PT is equals to 175. P naught A is given as 100 and XA we have to calculate, and PB is given as 200. XB we have to calculate. Okay. So on solving this, PB we have written as 200 and XA we have written as 1 minus XA we have written. So on calculating this, what it is, 200 minus 200 XA. Okay. This is only written here. So XA, on solving XA we will get it as 0.25, and we have to calculate what? Ya also. Ya, which means the mole fraction in vapor phase. So vapor phase, what happens in vapor phase? Na, this its formula comes out to be Pa by P total. So Pa is 100 and total we can calculate, which is 0.14. 0.14 is the total vapor pressure in vapor phase. Sorry, mole fraction in vapor phase. Okay, mole fraction in vapor phase, and Xa is the mole fraction in liquid phase. So 0.25 is the correct answer, and it is 0.14, which means option number 2. Option number 2 is the correct answer for 59 question. Next is question number 60. Question number 60 says that if the molality of the dilute solution is half, then the value of molar depression constant will be. What will be the value of molar depression constant? Okay. So if the molarity of the dilute solution is double, the value of molar depression constant remains unchanged. Okay, it remains unchanged because the molar depression constant is a characteristic property of the solvent and it has to do nothing with the solute concentration. Okay, it does not depend on the solute concentration, it depends upon the solvent. So the answer will be remains same. Okay, option number 3, yeah, remains same. Next is question number 61. In question number 61, which of the following has the least freezing point? 1% sucrose, 1% NaCl, 1% CaCl2 or 1% glucose. So in the freezing point also, na, it's depend upon the number of particles of solute. Okay, how many particles of solute are there after dissociation. So which will produce the maximum number of ions at lowest freezing point? According to the sucrose, it will not dissociate into any ions. NaCl, it will dissociate into 2 ions. CaCl2, it will dissociate into 3 ions. So it will have the maximum number of solute particles and therefore it will have the lowest freezing point. So least freezing point is only asked. So option number 3 is the correct answer. Okay. Question number 62. Next is question number 62. The plot of osmotic pressure versus concentration for a solution gives a straight line with a slope of 25.73 liter bar per mole. The temperature at which the osmotic pressure measurement is done is. R is given. So now see this question. The plot of osmotic pressure versus concentration for a solution gives a straight line with a slope of. So slope here is given as 25.73 liter bar per mole. Okay, the temperature at which, so temperature is asked here and R value is given. So by the formula of osmotic pressure, concentration into gas constant into R. So which means that pi is equals to CRT. Now slope, we know that it is R into T. Slope is given as 25.73, R value is given, and from there we can find out the temperature. So what will be the temperature? It will be 309.47, 309.47, which is approximately equals to 310 Kelvin. So here it is given in Kelvin and the options are in Celsius. So we just have to convert it into Celsius scale, which is 37 degrees Celsius. Option number 3 is the correct answer. Okay. Next is question number 63. Which of the following statements are true about osmotic pressure? Which is true about osmotic pressure? The first statement says that the flow of solvent from solution across a semi-permeable membrane can be stopped if some extra pressure is applied on the solution. Statement number 2 says it is the pressure that stops the flow of solvent towards the solution, and statement 3 says that it is the pressure that allows the flow of solvent across the semi-permeable membrane. So we have to find out that which of the followings are true for the osmotic pressure. Now we know that osmotic pressure depends upon the temperature and concentration, but it is independent of the nature of the membrane. Okay, it is independent of the nature of the membrane. So the flow of solvent from its side to solution across the semi-permeable membrane can be stopped if some extra pressure is applied to the solution. Okay, this flow can, pressure that just stops the flow of solvent is called the osmotic pressure of the solution. Okay, so option, which will be the correct option here? So on reading this, what you will get, that Option 1 and 2 are correct. Okay. Option 1 and 2 are correct options. So option number 1 is the both 1 and 2 are correct option. So here the details about the osmotic pressure is only given. Question number 64. Next is question number 64. A cane sugar solution has an osmotic pressure of 2.4 atm at 300 Kelvin. So osmotic pressure of cane sugar is given as 2.4 atm. What is the strength of the solution? What is the strength of the solution, which means the concentration is asked here. Value of R is given as 0.0821 liter. Okay, and temperature is also given as 300 Kelvin. So all these are given. So we will use the formula pi V is equals to NST. Okay, so pi is equals to N by V we know, and ST which is equals to CST. We have to find out the concentration only na. So directly we can write that pi is equals to CST. Okay, and C is equals to pi by ST. What will be C? It will be pi by ST. Now pi is given as 2.46 and S and T. S we know that S is the 300 Kelvin. S here is T is sorry ST, no, it should be RT. CRT, nah. It should be RT. So temperature is 300 and R is 0.0821, which comes out to be 0.1 molar. So osmotic pressure for this question will be 0.1 molar. Okay. Next is question number 65. The freezing point depression constant Kf of benzene is 5.12 Kelvin kg per mole. The freezing point depression for the solution of molality of 0.078 molar containing a non-electrolyte solution in benzene is rounded off up to 2 decimal places. Okay? Which means that the freezing point depression constant of benzene Kf is given as 5.12. Freezing point depression for solution of molality. Molality is given as 0.078 molar. Containing a non-electrolyte solution in benzene is the freezing point depression for solution of molality 0.078 molar containing a non-electrolyte solution in benzene. Okay, we have to find out. So question number 65. Kf is equals to, yeah. So for question number 65, so the question for 65, Kf value is given as 5.12 Kelvin kg per mole. M is given as 0.078 molar. Okay. So these two values are given. On putting these values in equation 1. What is equation 1? Delta Tf is equals to Kf. This is the formula for delta Tf. It is Kf into molality. Okay. So this, on putting the values in this formula, we will get Tf as 0.3996 39936. Okay. 39936 we will get Tf value. On rounding off to 2 decimal places, the freezing point depression is approximately equals to 0.40. So option number 2 here is correct option for question number 65. Next is for question number 66. In question number 66, what is the appropriate value for the vapor pressure of the solution at 45 degree Celsius with a mixture of toluene to hexane in a molar ratio of 3:2? Okay. At 45 degree Celsius, the vapor pressure of toluene is 250 mmHg and that of hexane is 380 mmHg. Assume the ideal behavior. So this is the appropriate value for the vapor pressure of the solution. Now, so the ratio is given as 3:2 and the mole fraction of toluene we will calculate as 3/5 and hexane we will calculate as 2/5. So this type of similar question we did above. So only the values are changed. So for what we have to calculate the vapor pressure, right? The vapor pressure on putting this value we will get as 302 mmHg. So 302 mmHg is the correct answer for this question. Option number 2. Next is question number 67. For question number 67, intermolecular forces between two benzene molecules are nearly the same strength as those between the two toluene molecules. For a mixture of benzene and toluene, which of the following are not true? Okay, so for this question, the options here delta mix of H is equals to 0, delta mix of V is equals to 0, these will form minimum boiling azeotrope, these will not form ideal solution. So among all these four options, let us see which is the correct one. So P naught is equals to P naught AXA. If the solution is made up of two components which are liquid, then delta mixing equals to 0 and delta V mixing equals to 0. Okay, so which is not true? Option number 4. So if these two situations are followed only, then only it will form an ideal solution. But in this case, these two are not followed, which means that this will not form an ideal solution. Option number 4 is the correct option. Now, question number 68. For question number 68, the assertion says that when NaCl is added to water, a depression in freezing point is observed, and the reason for this is given as the lowering of vapor pressure of a solution causes depression in the freezing point. Okay, so let us see on assertion and reason which is correct and which is incorrect. Assertion and reason both are correct, and the reason is the correct explanation of assertion. Okay, option number 1 will be the correct option. Let us see why. Because when NaCl is added to water, a depression in freezing point is observed, and which is due to the lowering of vapor pressure of the solution. The lowering of vapor pressure is observed due to the intermolecular interaction between the solvent solute particles. This is only given na. The lowering of vapor pressure causes the depression of the freezing point. This is the reason. And the assertion is when NaCl is dissolved into water, a depression in freezing point is observed. So these two are the correct. So both assertion and its reason are correct options. For question number 69. Question number 69, the question says that the vapor pressure of an aqueous solution of sucrose at 373 Kelvin is found to be 750 mmHg, and the molality of the solution will be vapor pressure of an aqueous solution. Vapor pressure is given as 750 mmHg. Okay, and its temperature is given as 373 Kelvin. So on this we have to find out the molality. Molality small m we have to find out. So Pa is given as 750 mmHg and 373 Kelvin is given as the boiling point. So P naught here is 760 mmHg. We know that. Now M formula we can calculate. This is the formula. So M is equals to P naught minus P divided by P naught into 1000 by M of solvent. So P naught we know that it is 760. On solving this, we will get as 10 by 750, and it is 1000 by 18, which is 0.74. 0.74, option number 3 is the correct option. You can look into the detailed solution also. Okay. Question number 70. For question number 70, in a humidified atmosphere, the mole fraction of water vapor is 0.03. So mole fraction of water vapor is given as 0.03. If the total pressure of the saturated air is 1.5 atm, what is the partial pressure of dry air? We have to find out the partial pressure of dry air. We know that the mole fraction of vapor pressure is 0.03. Sorry, water vapor is 0.03, and what will be the mole fraction of gas? It will be 0.97, right? So P total is 1.5 atm is also given. So partial pressure of dry air equals to total pressure into mole fraction of dry air, which is 1.465 atm. 1.465 atm, which means option number 2 will be the correct option. In question number 71, next is question number 71. Which of the following pairs exhibits positive deviation from Raoult's law? Okay, so positive deviation of Raoult's law occurs when the solution's vapor pressure is higher than the Raoult's law predicted due to strong intermolecular forces between the molecules. So uh, why a molecule will experience the positive deviation, right? So it experiences the positive deviation only when the intermolecular forces between the molecules are stronger than the predicted Raoult's law. Okay, so among all these pairs, the pair which shows the positive deviation is of acetone and ethanol. Acetone and ethanol will show the positive deviation. So this is like a theory based question. You just have to memorize it. The examples you just have to memorize it. The reasons for positive deviation are also given, and the reason for negative deviation is also given. So you can look at this explanations. For question number 72. Question number 72 says the Henry's law constant Kh values of three gases X, Y and Z are 120, 3 into 10 to the power minus 5 and 40 kilobar. The order of solubility of these gases, we have to find out the order of solubility. So value of Henry's law constant is inversely proportional to the solubility of the gas. Okay. So higher the value of Kh, the lower the solubility. Okay, so the Kh value, if we see the order of Kh value, then A is greater than C and it is less than B. So the order of solubility will be opposite to this order, right? So B greater than C greater than A. B greater than C greater than A, which means, okay, it should be X, Y, Z, na? X then Z then Y. And in this case, it should be Y then Z then X. Okay, Y, Z and X. Y, Z and X, which means option 1. Okay, sorry. Y, Z and X. Option 4. Option 4 is the correct option. Question number 73 says two liquid A and B have PA naught and PB naught in the ratio of 1:3 and the ratio of number of moles of A and B in liquid phase are 1:3. Then the mole fraction of A in vapor phase in the equilibrium with the solution is equal to. So see, let us understand the question. In question number 73, it is said that two liquids are there. Okay, two liquids are there, A and B, which have the partial pressure PA naught and PB naught in the ratio. Ratio is 1:3, and the number of moles of A and B in vapor phase are 1:3. So number of no mole fraction of A in vapor phase is in equilibrium with the solution. Okay, this is a twisted type question. So let us try to solve this. Partial pressure of A, we know that it is K into 1/4, where K is the ratio constant and partial pressure of B is equal to 3K into 3/4. So vapor pressure is 10K. Vapor pressure is 10K by 4. Okay, now vapor phase of fraction of A, partial pressure of A, vapor phase of fraction of A is partial pressure of A by total pressure, which comes out to be 0.1. So 0.1 is the correct option. Okay. Question number 74. Question number 74 says the boiling point of an azeotropic mixture of water ethanol is less than that of both water and ethanol. Okay. Then the mixture will show the negative deviation from Rolle's law. The mixture will show the positive deviation from Rolle's law. Mixture will show no deviation from Rolle's law and it will be considered as a true solution. So let us see. The mixture will show positive deviation from Rolle's law. Why it will show positive deviation? Because the experimental value of vapor pressure is more than the calculated value. So for positive deviation, we just have read now another question that the value should be greater than the expected value in Rolle's law. Therefore, only the solution will show the positive deviation. So experimental value is less than the calculated value. So delta H mix is positive here and delta V mix is negative here, which means that option number 2, the mixture will show the positive deviation from Rolle's law. This is the correct option. Okay. Next is question number 75. In question number 75, 1 molar solution of carboxylic acid in benzene shows the elevation of boiling point at 1.518 Kelvin. The degree of association for dimerization of the acid in benzene is K for benzene is given here. Okay. So delta TB, we know that delta TB is equals to Kb into molality. Now delta TB, delta Kb into m, delta Tb we have to find out, and Kb into m, Kb is given as 2.53 Kb here, Kb is given as 2.53 kilokelvin and molality is given as 1 molar. Okay, so for what is I is the Ventov factor, it is delta Tb observed into delta Tb of non, which is equals to 0.6. So I is equals to, we know that this is the formula, right? And alpha is equals to 80% here. Degree of dissociation comes out to be 80%. 4 is 80%. Okay. Next is question number 76. In question number 76, if 8 gram of non-electrolyte solution is dissolved in 104 gram of N-octane to reduce its vapor pressure to 80 degree, the molar mass of the solute is. We have to find out the molar mass of the solute, and the molar mass of N-octane is given as 114 gram per mole. Now, Rolle's law can be used for solving the given question. So, Rolle's law says that, Rolle's law is used for solving the above question. And for mole fraction, if we combine it with its mole fraction, then delta P by P naught A is equals to NB by NA equals to WB by MB equals to MA by MB. This equation is there. Now, here what is delta P? Delta P is the reduction in the vapor pressure of solvent. P naught A is the vapor pressure of pure state. Na is the number of moles of solute, and Nb is the number of moles of solvent. So, on solving all this, delta P here. Delta P here is 100 minus 80, which is 20 degrees Celsius. 80% is given, na? It is reduced to 80% vapor pressure. P naught is 100, WB is 8 gram, and MA is 114. MA is 114, it is also given. So now when we substitute all these value, we will get MB. We have to find out MB. MB here is 40. So MB is 40. Option number 4 is the correct option. Okay. In question number 77, let us read the question first. The aqueous solution that has the lowest vapor pressure at a given temperature. Aqueous solution that has the lowest vapor pressure at a given temperature is 0.1. Sorry. Just ignore the background noise, because it's raining heavily outside. I'm sorry for that. So the aqueous solution that has the lowest vapor pressure at a given temperature. So 0.1 molar sodium phosphate, 0.1 molar barium chloride, 0.1 molar sodium chloride, and 0.1 molar glucose. So which has the lowest vapor pressure here? Now we know that the aqueous solution with the lowest vapor pressure will be 1 molar sodium phosphate. Why it is so? Vapor pressure is the pressure which is exerted by the vapor of a solution, vapor of a substance in a equilibrium with its liquid or solid phase. So these theories you can find out. We will come to the final answer in this question. So sodium phosphate Na3PO4. So on dissociation in water, it will form 4 ions. 3 moles of Na plus and 1 moles of PO4 3 minus. So it will form 4 ions total. So if 4 ions are produced, and in barium chloride 3 ions are produced, and in sodium chloride 2 ions, and in glucose no ions are produced. So if 1 molar of sodium chloride, it has the most number of solutes, so therefore it will show the lowest vapor pressure. Right? Sodium phosphate, option number 1. Question number 78. In question number 78, the question says that two liquids A and B form an ideal solution at temperature T when the total vapor pressure above the solution is 400 torr. The mole fraction of A in the vapor phase 0.4 and the liquid phase 0.5. What are the vapor pressure of pure A? Okay, the liquid A and B form an ideal solution at temperature T. The vapor pressure above solution is given as 400 torr. If the 400 torr is given as the total vapor pressure, then the mole fraction of A, and in the vapor phase is 0.4 and the liquid phase is 0.5. Yeah. Now, in the question it is given that the total vapor pressure is 400 torr, mole fraction of A is given as 0.4 and mole fraction of in vapor phase of A, vapor phase is given as 0.4 and in liquid phase it is given as 0.5. Now we have to find out the partial pressure of A. So what will be the formula for partial pressure of A? It is XA into vapor pressure of P by P total. So this will be the formula, na? What will be PA? PA comes out to be 160 torr. So now if we got the PA is 160 torr, then now we have to find out the P naught A. So for P naught A formula will be PA into mole fraction of A liquid. So PA liquid will be P naught of A will be 230.33. So you just have to put the values in all the formula. You just have to remember the formula, correct formula where it will be used. So 213.33 torr, which means option number 1 is the correct option. Okay. Question number 79. Question number 79. In question number 79, match the following. Okay. So 88 gram of CO. 88 gram of CO, it will form 2 mole of gases. Okay, it will form 2 mole. Now 6.02 to 10 to the power 23 molecules of H2, it will form 1 mole. So it will form 1 mole. 5.6 liter of O2 at STP, it will have 0.25. 0.25. 96 of O2 will be 3 mole, and 1 mole of any gas, we know that it contains 6.02 to 10 to the power 23 molecules. So it is just the simple questions. Okay, it is just about the simple questions that you have studied earlier also in class 9th or 10th. So option number 1 for this matching type question is the correct answer. Question number 80. In question number 80, the freezing point depression constant Kf of toluene is, Kf here is given as 6.20 Kelvin kg per mole. Determine the freezing point depression for the solution with a molality is given as 0.060 molar containing a non-electrolyte solution in toluene. Okay. Kf here is given, molality is also given. Now we have to find out the freezing point depression at a non-electrolyte solution. Non-electrolyte solution, which means that dissociation does not occur, which means we cannot find the I for this value. We cannot find the I. So Tf is equals to Kf into M. Okay. In this formula, if we put the values, then we get the Tf as, simply just we have to put the values in the formula. It is 0.372. 0.372, if we round off to 2 decimal places, it is 0.37, option number 3. Okay. In question number 81, what is in question number 81? Which of the following quantities varies with temperature? Which of the following quantities varies with temperature? Molality, mole fraction, weight percentage, or molarity? So molarity, it is defined as the number of, okay, definition we know. Since the volume of solution change with temperature due to thermal expansion, molarity will also change. So it will depend upon the temperature. Okay, molarity is dependent on the temperature. Let us see others also. Mole fraction, it is independent of temperature. Weight percentage is also not affected by the temperature. Does not depend upon the volume change caused by temperature. And molarity also, it is independent of temperature. Okay. So which is dependent on temperature? Molarity is only dependent. So option number 1 will be the correct option. Next is question number 82. Assertion says that molarity varies with temperature, and reason says that molarity is dependent on the volume and hence on temperature. Yeah, these two are correct. Okay, just we have read about the reasons and explanation for this question. Option number 4 is the correct option. Question number 83. In question number 83, a solution consisting of acetone dissolved in ethanol would most likely to demonstrate which behavior? So it will behave like, it will display a positive deviation of Raoult's law. It will display a positive deviation from Raoult's law. Okay. So Raoult's law question also we have done maximum of Raoult's law question, and its deviation is because it shows the greater values than the expected Raoult's law value. Okay. See, acetone and ethanol are both polar molecule and contain the carbonyl functional group. So ethanol can form strong hydrogen bonds with ethanol molecules due to presence of hydroxyl group, and acetone can form the weaker hydrogen bonds with ethanol due to steric hindrance. So when acetone is mixed with ethanol, they disrupt the hydrogen bonding network between the ethanol molecules, weakening the intermolecular interaction, which leads to a situation where the attractive forces between the individual acetone and ethanol molecules are weaker than the attractive forces of pure molecules. Okay, so these are the reason why there is a positive deviation is observed. Okay, you can read the full explanation about this question. Question number 84. If the molality of the dilute solution is doubled, what will happen to the values of the molar depletion constant? What will happen to the values of the molar depletion constant? So the molar depletion constant of the solvent is a characteristic property that remains unchanged regardless to the solution. This question also, I think it is repeated once more. So it will remain unchanged. Only the wordings are changed. Okay, it will remain unchanged. Next is question number 85. Question number 85 is an interesting question. So, two beakers of 500 ml capacity were taken. One of these beakers were labeled. I am using a different color. Two beakers of 500 ml capacities were taken. One of these beakers are labeled as A, was filled with 400 ml. So, this is filled with 400 ml water. Whereas the beaker installed as B is filled with 400 ml of 2 molar solution of NaCl. Okay. At the same temperature, both these beakers were placed in a closed container of some material and the capacity is shown. At the given temperature, which of the following statement is correct about vapor pressure of pure water and that of NaCl solution? So let's see. Option 1 says that vapor pressure in container A is more than the vapor pressure in container B. Option 2 says that vapor pressure in container A is less than vapor pressure of container B. Third says the vapor pressure is equal in both containers, and fourth says that vapor pressure in container B is twice the vapor pressure of container A. So what will be your answer? Which option are you going with? Okay. So option 1 will be the correct option. Let us see why. Because when salt is added to water, it makes the the vapor pressure of the solution decreases. When we add salt, which means when NaCl is added, what happens that the vapor pressure of the solution decreases. Why? Because surface covered by the solvent molecules will lead to the decrease in the number of solvent molecules escaping from the surface corresponding to pure solvent, which means that a layer of NaCl molecule is formed which decreases the number of solvent molecules to escape from the pure solvent. Okay. Vapor pressure and colligative properties definition is given. You can refer to the definition of vapor pressure and colligative property. Let us see. So NaCl, this solution container has 2 molar NaCl, which means that there are significant amount of dissolved NaCl in water. Now, due to the presence of these solute molecules, what happens? The vapor pressure of water in container B will be lower to compared A. Okay. Why it is lower? Because the volume of NaCl, because as the volume of NaCl in both the container is same, but what happens now? That the presence of dissolved NaCl, it disrupts the water molecules for escaping into the vapor phase. Okay, are you clear with this? Because see, if let us consider that if a container has only water, okay, and if another container has NaCl dissolved in it, so water, when it is converted into its vapor phase, now it can escape easily. The water molecules can be converted easily into gas and it can escape easily. But the solution which is containing NaCl, the vapor pressure, although it is the same as container A, but it will not escape that easily. Okay, which will lead to the lower in the vapor pressure. Therefore, the vapor pressure is container A is more than in container B. Vapor pressure of container A will be more because the solute particles cannot escape the container B. Okay, option number 1 is the correct option. In question number 86, in the graph given below, what is the slope of the line represent? So this type of graph is we have done na this type of graph, straight line passing through the horizon, it will represent the Henry's law. Option number 3. Okay. In question number 87, which of the following statement about the composition of vapor over an ideal 1:1 molar mixture of benzene and toluene is correct? Assume that the temperature is constant at 25 degrees Celsius. Now, vapor pressure data is also given. Benzene is having vapor pressure of 12.8 kilopascal and toluene is having vapor pressure of 3.85 kilopascal. Okay, question number 87. See, a solution that contains the maximum amount of solute which can be dissolved in a given amount of solvent at a particular temperature. Okay, saturated solution, we know that the definition of saturated solution. Now, binary solution contains two components which might be solid, liquid or gas. Isotonic solution, we know. Okay, it is for question number 88, I think. Wait a second. Yeah, it is for question number 88. This solution is for question number 88. This is for question 89. Yeah, so question number 87. In question number 87, it is written that which of the following statement about the composition of vapor over an ideal 1:1 molar mixture of benzene and toluene is correct. Assume that the temperature is constant at 25 degrees Celsius and vapor pressure is given. Benzene, it is vapor pressure is having 12.8 for benzene. For benzene, the vapor pressure is 12.8 kilopascal, and for toluene it is 3.85 kilopascal. Okay, so now we have to find out that which statement is true. The vapor pressure will contain a high percentage of toluene. The vapor pressure will contain equal amount of benzene and toluene. Third one, not enough information is available, and fourth option says that the vapor pressure will contain a higher percentage of benzene. So option 4 will be the correct option. Vapor pressure will contain higher percentage of benzene. Why? Because the partial vapor pressure, here it is the partial vapor pressure of benzene and partial vapor pressure of toluene is given. Okay, so the partial vapor pressure of benzene is more, it is greater, and for toluene it is less, so therefore it will contain the higher percentage of benzene, okay, in the solution also. Option number 87 is correct option. Next is question number 80. 88. Okay, next is question number 88. Yeah. So it is a matching type question. Saturated solution, binary solution, isotonic, hypertonic solution, solid solution, and hypertonic solution. Hypertonic. Yeah. So we have to match all this. Let us see. So what is a saturated solution? It contains the maximum amount of solute which can be dissolved in a given amount of solvent at a particular temperature. So option A. Option A will have the second one. Second one as the correct option. Okay. Next is binary solution. Binary solution, which means a component having two components. Binary means two, which means solution having the same osmotic pressure and the given temperature in that of given solution. Next is isotonic solution. Isotonic solution, it is having the same osmotic pressure. Okay, it is having the same osmotic pressure. Okay, I think option is incorrect here. Wait. Yeah, for saturated solution, what we have seen that a solution that contains maximum amount of solute. Okay, that contains maximum amount of solute that can be dissolved in a given solution. So for A option 4 is correct. For A option 4 is correct. Okay, for A option 4 is correct. So option 2 will be automatically the correct option. Let us see the others also. Binary solution, which means it is having two solutions, two components. So option C. Isotonic solution, which means that it is having the same osmotic pressure. at the given temperature. It is having the same osmotic pressure, also it is having the same osmotic pressure. So option C will have option 1 as the correct option. Next is hypotonic. Hypotonic, which means that it will have less osmotic pressure than the other solution. It will have less osmotic pressure. Okay, option D will have 2 as the correct option. Next is solid solution. It is in solid phase, option 6, and option F, hypertonic solution, it is osmotic pressure is more than that of another, option 5. So option 2 will be the correct option for question number 18. Not option 4, but option 2 is the correct option. Okay. Question number 89. The value of Henry's law constant for argon, carbon dioxide, methane and formaldehyde is respectively 40.3 Kelvin bar, 16.7 Kelvin bar, 0.413 Kelvin bar and 1.83 into 10 to the power 5 Kelvin bar. Okay. At 298 Kelvin, the correct order of their solubility is, we have to find out the correct order for solubility of these all. Okay. Question number 89. Yeah, here it is, question number 89. So higher the value of Henry's law constant, lower is the solubility of water. So the order of KH value is ArCO CH4HCO. So this is the order. Okay. So which means that order of KH value only we have to find out now. So Ar will be greater than CO2, then CH4, then HCHO. Okay. Which means option number 3. Option number 3 will be the correct option. Okay, okay, reason once we can read the reason. The higher KH value, it signifies that a weaker interaction between the gas molecules and the solvent molecules are there, which means that the lower solubility is in the solution. Since argon has the highest KH, it will have the weakest interaction with the solvent and therefore the lowest solubility. Formaldehyde has the lowest KH, indicating the strongest interaction with the molecules and which leads to the highest solubility. Therefore, the order of solubility from least to highest is this. Option number 3 is the correct order. Okay. Next is question number 90. Match the laws given in the column 1 with the expression given in column 2. Rawls law. Rawls law has the this equation. So option A has option 3 as the correct option. Option 3 is correct in option 1 only. So this is the correct option. Now Henry's law will be P equals to KHX. So option B will have 5 as the correct option. Okay. Elevation in boiling point. Elevation in boiling point. What is the formula for this? Delta TB is equal to KB into M, which means option 4. Option 4. Depression in freezing point. Depression in freezing points, which means TF is equals to KF into M. So this is just the formula based question. This is just the formula based question. Okay. You just have to remember the formulas of the. Okay. Question number 91. Which of the following statement is or are correct for KF? KF depends upon the nature of solvent. KF is known as the freezing point depression constant or molar depression constant. KF is known as the cryoscopic constant. Select the correct conclusion derived from the equation. Now, the proportionality constant depends upon the KF depends upon the nature of the solvent and is known as the freezing point depression constant, and its uh, or cryoscopic constant unit is Kf equals to Kelvin kg per mole. So it depends upon the nature of solvent. Yes, it known as the freezing point depression constant. This is also correct. Kf is also known as the cryoscopic constant. So these three are correct, which means that all are correct. Okay. Question number 92. In question number 92, Henry's law constant of oxygen is 1.4 into 10 to the power minus 3 mole per liter ATM inverse at 298 Kelvin. How much oxygen is dissolved in 100 ml at 298 Kelvin when partial pressure of oxygen is 0.5 atm? Okay, so X is equals to Kh into P of O2. It will be 7 into 10 to the power minus 4 per mole. Now, number of moles of oxygen dissolved in 1000 ml is 7 into 10 to the power minus 4. Number of moles of oxygen dissolved in 100 ml, it will be 7 into 10 to the power minus 5. Now, weight of oxygen in 100 ml, it will be 7 into 10 to the power minus 5 into 32, which means that 2.24 is the correct option. 2.24. Option number 4 is the correct option for this question. Question number 93. For detailed solution, you can refer here, okay? Everything is given in the detailed solution. Question number 93 says the solution which has the highest boiling point. So the highest boiling point, we have to use the formula delta TF is equals to I into KF. So highest boiling point will be for CaCl2. Okay, CaCl2, it will be 0.9 kF. Others will have the less boiling point than first. Question number 94. Question number 94 says osmotic pressure of 20% W by V CaNO3 whole to solution at 0 degrees Celsius will be. What will be the answer? For dissociation of CaCO3 minus, we have to use this formula I is equals to 1 minus A plus 2A. So after dissociation we will calculate as this, so it comes out to be 1 plus 2A. So A is equals to 1. So what is I here? I is the given weight is 20, volume is 0.1, temperature is also given, molecular weight of CaNO3 we have calculated as 164 gram. So osmotic pressure value we can easily calculate. It comes out to be 82 atm. 82 atm, option number 2. Okay. Question number 95 says which of the following shows negative deviation from Rolle's law? Negative deviation from Rolle's law. So we are reading about the positive deviation till now. Okay. So negative deviation is shown by acetone and chloroform. Acetone and chloroform, why? Because there is a hydrogen bonding which is formed in between these two. Okay, hydrogen bonding, what it will do? It will decrease the value it will decrease the value from the Rolle's law. Okay. See, in case of CHCH3 and acetone, CHCH3 has a positive CCl bond and it can form hydrogen bonds with other CH3 molecules. Acetone is a polar carbonyl group and it can also form hydrogen bonds. So when these two are mixed, some hydrogen bonds between the pure components are disrupted. However, the new hydrogen bonds can form between these two and the intermolecular spaces are stronger. So these stronger forces of attraction, they will result in a negative Rolle's law deviation. Okay, it will result in a negative Rolle's law deviation. Option number 1. Question number 96. For question number 96, an ideal solution is not formed when the components have slight solubility. Okay, an ideal solution, we know that it obeys the Rolle's law and all concentration, and during the formation it has no enthalpy change. So at high solubility, see, solvent-solvent interaction are equal to solute-solute interaction, and at high solubility, no ideal solution can be formed. Question number 97. The plot of osmotic pressure versus concentration for a solution yields a linear relationship with a slope of 30.50 liter bar per mole. What is the temperature at which osmotic pressure measurements were conducted? So pi is equals to CRT. Slope is RT by slope is RT. Okay, slope value is given as 0.30, R value we know, and temperature we can calculate as 367 Kelvin, and on converting it into degree, it is 94 degrees Celsius. Okay. For question number 98, Which gas when passed through dilute blood will impart a cherry red color to the solution? The gas which will impart the cherry red color to the dilute solution is carbon monoxide. Okay, this carbon monoxide. Why? What is the reason for it? Okay, it has higher affinity for hemoglobin. So when carbon monoxide enters the bloodstream, it binds with hemoglobin to form carboxyhemoglobin. Okay, and what is an impact on oxygen transport or the formation of carboxyhemoglobin reduces the amount of oxygen that hemoglobin can carry, and it disrupts to the tissue, leading it to condition called carbon monoxide poisoning. Okay, and cherry red color is observed because the oxygenated blood appears bright red due to oxyhemoglobin. Now, instead of oxygen, if carbon monoxide is combined with the blood, then it will form a cherry red color. Okay, and it is a sign of monoxide poisoning. In question number 99. In question number 99, the latent heat of vaporization of water is yeah. So next is question number 99. The latent heat of vaporization of water is 540 calorie per gram at 100 degrees Celsius. Kp for water is okay. So let us see this. Let us see the solution for this question. Okay, so where is the space? Here I am writing. So question number 99. In question number 99, the latent heat of vaporization. The latent heat of vaporization is given as 540 calorie per gram. Okay. Now, temperature here is given as 100 degrees Celsius. So, if we convert it into Kelvin, what will happen? 270 plus 100, which is 373 Kelvin. Okay. Now, we have to find out the Kb, not Kp. It is Kb. So, the formula for Kb of water, for the formula for Kb, it is, what is the formula for Kb? It is uh, RT square by 1000 into latent heat. Okay, R is the gas constant here. So the value for Kb for calorie, if we considering it as calorie, R will be 2. Okay, R we will consider it as 2. Then Kb is equals to 2 into temperature is 373 whole square. It is 1000. It is 1000 into L. L we have calculated as what? L is given as 540, right? So here from here Kb value comes out to be 0.51. Okay, Kelvin per mole. 0.51 Kelvin per mole. So option number 3 for question number 99 is correct. Option number 3, not option number 2, option number 3 is correct. Okay. For question number 100. The ratio of vapor pressure of a solution to the vapor pressure of the solvent is okay equal to mole fraction of the solvent, proportional to mole fraction of the solvent, equal to mole fraction of the solute, none of the above. So the ratio of mole fraction, the ratio of vapor pressure of the solution to the vapor pressure of pure solvent is equal to mole fraction of the solvent. Okay, it is equal to the mole fraction of the solvent. The ratio of vapor pressure of the solvent to the vapor pressure of the pure solvent can be described as Raoult's law. It is Raoult's law mainly. So Raoult's law states that the vapor pressure of the solvent above a solution is equal to the mole fraction of the solvent times vapor pressure of the solvent. Okay, so this is the formula for Raoult's law. You can read the remaining part also for detailed explanation. Okay, so here we are concluding the chemistry explanation.